So what I'd like to get back into, Taryn gave us three awesome, how many of you guys have heard of mean and median and mode? Yeah, most of you, if not almost all of you. Exactly. I want to make sure we have a working knowledge not only of how they're computed, but also of what they mean, because they all mean a slightly different thing generally, on average. Sometimes they mean the same thing, but very often they result in different values. So the mean is what most people usually think of when they hear the word average. That's usually what is implied by the word average. As soon as I said, what's the average number of lollipops that these folks had, you guys immediately went to, let's go add them up and divide by. So you guys are used to doing the sum of the data divided by how many data points there are. So we had 10 data points up here. Each one of you that was standing here is 10 data points. And you were trying to add up all the data points, 9 plus 0 plus 1 plus 1 plus 4 plus 5. You know, that's all very good. Just FYI, we like to use certain symbols in this class just because they make life easy for us. Sum of, whenever you're talking about adding anything up in this class, there's a very, very handy symbol. Capital sigma, it's a Greek letter. It's the S sound in Greek. This is a default symbol that is used to talk about adding stuff up in mathematics. Has anybody seen it in mathematics before? Or in physics or science? Couple of you, yeah. Big sigma just means you're adding a bunch of stuff up. Data in general in this class will be represented with little x values. So when you see big sigma x, it means add up everything you got. That's a fancy way of saying add up everything you've got. Now I say it's fancy, it's not really fancy, it's just convenient. It's a convenient way of saying that, so we don't have to actually say it to each other. It's a little bit of shorthand. Mathematicians and statisticians love shorthand because it gives us a really, really, really slick way of being able to describe a sentence with a symbol or two. And then how many data points? We get tired of writing that too. The number that is, or the variable that is usually used is little n. Little n for the number of data points. So big sigma x over n means add up everything you got and divide by how many you got. You'll see this constantly in this class. I like using those symbols. I'm going to move this equal sign down a little bit. I like using these symbols because they do give us a shorthand, and we can actually do stuff with them mathematically, which is even more fun. And statisticians even have invented a shorthand for the name mean. They don't even call it mean sometimes. If they're printing the text, they call it X with a little line over the top of it. It's called X bar. X bar. This is the first of many, 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 many times we'll mention this in here. X bar. X bar. So it's also called the sample mean. The sample mean. We can get that as I'll put that up here. The sample mean. There is a population mean. There is a population mean. We've talked about this, right? Your population has an average. Do you usually know what it is? And I don't care what we're talking about, whether we're talking about kids or whether we're talking about weight or... Do you usually know what your population's average is? Think about what it would take to know what the population's average is. What would you have to know? For example, average weight. Average weight of the United States. You would have to know every person in the United States' weight. Possible to do?
Yeah.
No, somebody just died in the time it took me to say all that. And guess what just happened?
Somebody
was just born. Oh, but guess what just happened?
Somebody else died.
Somebody else just died. But now a pair of twins was just born. So you see, you can't do it. You can't get the population mean with any kind of precision because it's too hard to get it.
What about between 20 and 30?
Say that again.
What about between 20 and 30?
There's still too many of them, don't you think? Between 20 and 30? I mean, the idea is there's just so many. Now you can make it very specific. Suppose you are my population right now. My population becomes Math 243, Monday, Wednesday, CRN, whatever the hell it is, 42776. Could I get your average weight? I mean, I could weigh all of you right now and then average it. I mean, I could totally do that. But that's kind of a fictitious population, right? I mean, what would that gain for me? The average weight of Americans is a good thing to know if you're interested in tracking like obesity rates or just trending nutrition. The average weight of Americans has gone up over the past 200 years. Our nutrition is generally better than it was 200 years ago. You know, our life expectancy is longer. But the thing is you don't check every single American. You check a sample of Americans. And that's where this symbol comes in. X bar becomes the sample mean in general.
Sampling.
You're sampling from your population, exactly, Sylviana. So, let's think about some words we can... I do want to use this calculation, but some words to think about what that formula does. So when you add it all up and divide by how many, what number does that give you? An estimated... So suppose we go back to the average weight. Suppose the average weight of an American is 150 pounds. Let's just make a number up. 150 pounds. Boom. Done. What does that mean? What does that mean? Think of lollipops.
Nothing if not height.
Say that again.
It means nothing if you don't have.
No, what is the number itself? Ignore any correlation with height or obesity or anything like that. What does the number, average of 150 pounds mean? Taryn?
Doesn't it mean like most people are outside of that?
Well, you have to define most.
Well,
Suppose you took everybody in America and lined them up from lightest to heaviest.
it's in the middle.
It's the middle. Tell me more. I like that idea of middle. Give me more with middle. I heard a voice over here, middle. Riley, it's middle. Suppose the person on the end is 460. But the person down here is 1. What does that person that's 460 do to the person that's 1?
Give us weight to that one.
Gives them some of the weight. Now you can't actually do this without a knife. But you would take some of that weight that's over the average and donate it to those that are under the average.
Share it.
You're distributing it evenly, which means there are 310 million Americans, yes? If the average weight was 150 pounds, what that means, essentially, is that if every single person in America weighed 150 pounds, you would have the exact same total weight of Americans as we do right now. With the 1 pound person, and the 460 pound person, and the 75 pound person, and the 225 pound person, those people have a total weight, correct? They have a total weight. It's right here. This is the total weight of all their weights. If you spread that out evenly across all the people, they would all weigh 150. I'm not saying it's realistic, I'm saying that's what an average is. This is a number we use all the time, right? But do you see how you're looking at me right now? You're kind of like, this doesn't make a whole lot of sense. I'm glad, because this is something you have to be careful with. Is it always a good idea to talk about an average? You see, you're starting to learn it's not always a good idea to talk about an average, because sometimes the average is misleading. What this basically does, I like to think of this as either the balancing or the sharing measure of center. These are just words I use. Balance or share. It's if every single element of your data set had to share the resources that were in the data set, it's the number that they each have to do that sharing. Like the lollipops. If I gave each of those 10 people 3, you'd have the exact same number of lollipops as you guys did, but you'd all have the same number. Now the reason I brought this up, because Riley, as soon as I started saying the share, she covered her stuff. It's like, I want these. That's good. Very often you hear about socialism in America. That sounds socialist. Socialism, that's okay, and you can have them. Now, there's more up here. Absolutely, you guys take these. I don't want these back. The idea is when you hear Americans complaining about socialism, it sounds like socialism. They don't like this idea when applied to things like wealth. Because what it means is, suppose somebody has a lot of wealth, this would imply, suppose the average earnings of an American, I don't know, throw a number out there, the average annual earnings for an American, throw a number, 60,000? Suppose it's 60. Well, Bill Gates, who makes 30.2 million, would then have to give up 31.1999 million and give it to some people else to spread it to give that average.
Even Bill Gates realizes that he has way more of the wealth, and that's why he distributed it.
Well, he's a philanthropist.
Yeah.
He does that automatically by his
socialist.
Bill and Melinda Gates Foundation. But that's the idea. People don't like averages when they're applied to things like money, because it involves giving to those who might be perceived to be undeserving. I'm not going to get into that discussion because anyway. I'm going to stop that right now. But that's the idea. Averages, this is what an average is. An average is a redistribution so that the share and the balance, that's an R, that's not shaping, that's sharing, sorry. Sharing. That's clear as mud, right? Yeah, good. So here, let's practice. Let's practice. I collected some data from you guys on Wednesday. Here it is. Remember how I asked you how many keys you got with you? Yes.
Yeah.